Hello. Today we're going to be talking about exponential functions. We're going to start off with a warm-up A, B, C, and D, just looking at different functions and what their graph looks like. So go ahead and pause the video and do A through D individually, and then come back here to see if your answers are correct. Okay, let's take a look at A. We get 1/4, 1/2, 1, 2, and 4 for your Y values. You can see your domain and your range. The asymptote here is a line that the graph approaches off to infinity. And it never actually touches it. So we are going to show that asymptote on our graph as a dotted horizontal line. You can see from left to right, this graph is increasing. It kind of looks like a slide here, but going up. This is exponential growth. Whereas for B, it goes the other way. We have 4, 2, 1, 1/2, and 1/4 because each time we are dividing by 2. And so this one also has an asymptote here at y equals 0. If I take half of an object for forever, I'll still have a teeny smidge. I'll never get down to 0, which is why we have that asymptote. This one does look like a slide. It is decreasing for forever from left to right. So this is known as exponential decay. So that's what parts C and D kind of get at. These are both exponential functions, where the first one was growing for forever from left to right, and the next one is decreasing for forever from left to right. So that the first one was growth, and the second one decay. So we're going to be able to graph exponential functions by creating tables of values and then moving those all around, left, right, up, and down. Your A value does everything that A has done from in the past. So it's going to compress vertically. This is not supposed to be compressed right there. It is supposed to be stretches vertically. And it should compress. It is shrink, that's fine. But we're going to go ahead and call it compress vertically if your A value is in between 0 and 1, and it's going to reflect over the x-axis. The H value is up with the X here. So it's a little bit different than the ones we've done in the past, but it is still with the X. It's going to move right and left, and it's always going to be the opposite of what you think it should. So if it's X minus a number, it moves right. And if it's X plus a number, it moves left. K is your up and down, just like it normally is. The biggest thing with K is that's always going to be your asymptote. So whatever you're moving up and down, that's going to change your asymptote, which changes your range as well. And the other thing about this one is exponential functions have that extra value, that B value, that is your base. That's what determines if it is growth or decay. So it's going to be all about the base when you're graphing exponential functions. So to create your table of values, I'm going to eliminate A, H, and K for this one. Looking at your exponential functions, it's going to be completely based off of whatever your base is. We're going to use -1, 0, and 1 for our exponents because those are the nicest ones to actually evaluate. So if you take any random B value and raise it to the negative first power, you're going to get back out 1 over B. If you plug in 0 for your exponent, anything to the 0 power is always 1, and anything to the first power is always itself. So this table of values is going to be something that we need to know because every exponential function, the graph looks completely different based off of your base. And if you can create this table, then we can start moving those graphs all around. So for instance, if we had y equals 5 to the x, your table of values would be -1, 0, and 1, and 1/5, 1, and 5. Whereas if you had something like 2/3 to the x, your table of values would be -1, 0, and 1. Anything to the 0 power is 1. Anything to the first power is itself. But then the tricky one for this one is 2/3 to the negative first power. If you raise each of these to the negative first power and move them, you get the reciprocal of the base. So this would be the table that we would then move all around for a base of 2/3. So let's take a look at what that actually looks like then, all put together. So for number 1 here, 2 is our base. Okay, so we're going to identify that right up front. Our A value is not there, which means we have a stretch of 1. Our H value is going to be -3 to show that we are going to move left 3. Our K value is -5 to show that our graph is going to be moving down 5. So let's go ahead and take a look at what our table would be for this one. So we have X and Y. I'm going to write -1, 0, and 1 off to the side. And I'm going to do the reciprocal of the base, 1, and the base, but again using 2 as my number. In essence, I'm doing 2 to the -1st power, 2 to the 0 power, and 2 to the 1st power. Upon your x values, you are going to add h, just like our square root and our cube root functions. For these ones, we want to make sure they are going left 3. So our numbers would become -4, -3, and -2. For our y values, we're going to multiply by a and then add k. So we're going to stretch by 1 and then move down 5. So this first one becomes -4.5. This next one becomes -4. And our last one here becomes -3. These are new points that we are going to graph. So -4, -4.5, -3, -4, and -2, -3. So right now, these are going to be enough to get a good sketch of the graph, but we want to kind of do a little bit more to picture what this should look like. So we're going to bump over to the asymptote here. So we take our graph, and when we move it left 3, it doesn't change the asymptote, but when we move it down 5, it does. So the asymptote for this one should be y equals -5. Which means right away over here, we can go ahead and draw that horizontal line through -5. Now, this kind of helps us graph this left half of the graph and make it a little bit better there. Before I do that, though, I'm going to go ahead and fill the rest of this out. Your domain is negative to positive infinity for all exponentials because you can plug any number in. Your range for this one starts down at -5 and goes up for forever. Your y-intercept is going to be 0, some number. So I was waiting to graph this until I actually figured out what my y-intercept is, because that could help me actually graph it a little bit nicer. So we get 2 to the 0 plus 3 minus 5. So 2 cubed minus 5 ends up being 3. And that point there does actually help us with that shape of the graph. We can make it into this slide shape, which now we can see from the graph it is growing from left to right, and that is because our base here was 2, which means it is exponential growth. Let's go ahead and try another one then. So for this one here, our base is 2/5. Our A value is -3. Our H value is +4 to show right 4. And our K value is +2 to go up 2. So let's go ahead right now and write our asymptote. It's always y equals our K value. And we could even graph that immediately if we'd like to. Let's go ahead and now come up with our table of values. We're going to do -1, 0, and 1. For this one, since my base is a fraction, sometimes people like to just start with to the 1st power because you always end up with whatever you started with. Anything to the 0 power is 1, and anything to the -1st power is going to be the reciprocal of what you have. So it's going to be the 5/2. For your x values, you're going to move them all right 4. For your y values, you're going to multiply by -3 and then add 2. So go ahead and pause the video and figure out your new table, graph it, and do your domain, your range, and then stop there. Okay, so for this one here, you can see your table value should be 3, -5.5, 4, -1, and 5, 0.8. We can graph that and show that our graph is getting close to the asymptote and never touching it. Our domain negative to positive infinity, and our range negative infinity to 2 with a parentheses. Your y-intercept is going to be 0, some number. This is something that you are able to use your calculator on. I would not expect you to do this one without your calculator. So go ahead and type in 0 for x and figure out what you get for y. And I got a decimal 115 or -115.19. Now for growth or decay, we have kind of a conflict going on here. So our base here is a fraction in between 0 and 1. So you would say it's decay. But if you look at your graph from left to right, your graph is not going down or decreasing from left to right. It's increasing from left to right. So what's happening here is our A value is negative, which flips it over. Anytime you have a negative A, that means it's going to be neither growth nor decay because your graph conflicts with what you would normally say. You'd say decay, but if you look at your graph, it's not decreasing over time. So a negative A means neither growth nor decay. Okay. So number 3 here, we're just going to set up our table for this one, and then from then on, you can go ahead and try it more individually. Our A value is 0.1, our H value is 0, and our K value is -3. Our base is 6. So when we do -1, 0, and 1 for our X values, our Y values are 1 over your base, 1, and the base. So your X values aren't changing. Your Y values, you're going to multiply by A and then add K. So you're going to multiply by -1 or 0.1 and then subtract 3. So this would be something that you are able to use your calculator on. So let's go ahead and have you try this one and then come back to the video and see if you get the correct answer. Okay. So our graph would look something like this. It grows very slowly, but it does grow over time, and it's because of that 0.1 out in front. So we're going to move on to just a couple of application problems. Your application problems are going to be based off of exponential functions. A out in front is your initial amount. 1 plus r is your growth factor. So this right here is supposed to be 1 plus r. This is your growth factor. That's like your base. Okay, so if your base is greater than 1, it's growing. Whereas in the next one, 1 minus r would be in between 0 and 1 for your base, making it decay. R is your rate. You want to make sure you write your rate as a decimal. So if you have, for instance, 4.3%, it would be 0.043 when you're writing your equation. So let's go ahead and take a look at this first application problem. We have the initial amount here being 12,000. The culture doubles every day. So your base here is going to be 2. We don't need to do 1 plus 2 because the doubling itself is telling us the growth factor already. Our graph of this would start with 0, 12,000, and then the next day you'd have 24,000, and the next day after that you'd have the 48,000. So you can see that this is exponential growth with it doubling each time. And your y-intercept represents the initial amount. So the next video, we're going to try the other couple application problems. Thanks for listening.